Lesson 523, how can I solve it? So we've done all this work with exponentials and now logarithms, and we've went back and forth. We've learned properties. So now let's figure out how to solve these. So Eduardo thinks he can solve 6 to the x, right? So this is 6 to the x power. This is what we're talking about at the beginning of the chapter, equals 20, right? And he thinks he can solve it in just one step. So going from exponential to a log, this would be log base 6 of 20 equals x. Does that solve the equation? Sure, right? So we can plug this in a calculator, log base 620, boom, spits out an answer. Right now, it's going to be a decimal answer. So is it practical to answer their question? Is it practical? No, that decimal answer is probably not practical, but it still gets us there, right? So in C, she says she knows how to solve the problem using logarithms in another way. So she takes 6x equals 20, right? And she logs both sides, right? So this would be the same as like square rooting both sides. She's going to say, hey, I'm going to log both sides. So this is going to be like log 6 to the x equals log of 20, right? Then exponent rule brings this to the front, right? So this is x log base 6, or excuse me, base 10 of 6, and then log of 20, right? So then to solve, we would just divide by the log of 6. Okay, and this is actually going to get you the same answer. This and this are actually going to get you the same answer. Okay, and then part D says Eduardo's brother's taking calculus, says you can do the same thing with a natural log. So if you natural log both sides, um, again, same, exponent rule, and then divide by the natural log of 6, right? You're going to get the same answer. So there's 3 different ways to get there. And so, most people like this way of just going back and forth between exponential and log. But so, well, I'm not going to get ahead of myself, but so let's just do that way on 80. So if we look at 80 and we have 1.05 x equals 2, we would change this to log base 1.05 of 2 equals x. Again, we put this in our calculator, we get an answer. Okay, if you look at B, this would be 15, 3 to the x equals -6. First step, we would divide by 15. Okay, so this would get us 3 to the x equals -3 over 5. Sorry, -2 over 5. Right, but here's the thing. We can't get a negative, right? So this is no solution, right? The next step would have been to put this back into log form and to get our answer, but we should already know that we can't get that negative. There's no way we can get there from there. Okay, and then if you look at C, C's hard to see here, but -12, 10 to the x plus 3 equals -3. Okay, so subtract 3. We have -12, 10 to the x equals -6. Divide by -12. You get 10 to the x equals 1/2. Okay, then take it to a log. So log base 10 of 1/2 equals x. Remember, base 10 we don't have to write, right? Put that in our calculator. Again, it gives us that number. Okay, awesome. So using Anita's method to solve, right? So they're going to talk about something here, and I'm just going to use her method really quickly to solve this. So we evaluate that, right? And so her method, we would go 3 to the x equals 11, right? And then again, you would log both sides. Okay, the x would come to the front. You would have log of 3 equals log of 11, right? And then you go and divide by the log of 3. Okay, this, if you ever see this, right? So this right here, log base 3 of 11, and they write it as log of 11 over log of 3. That is what they're referring to as the change of base formula. They're changing the base from 3 to back to 10 base. Okay, and this was really useful like on older calculators that would actually only work with log base 10. So like the old TI-83s or anything before that actually wouldn't have that log where you could change the base. So So you had to use this. This is what you used to have to use on an older model calculator. So this works. So in the sense of like C, problem C here, where they give you this log of 7, a base 7 of 204. To rewrite that, you would just say log of 204 divided by log of 7, right? And that was that change of base formula and where it came from, right? So it's really just solving very simply. So let's move on here. 82. So let's solve A. So A, we have log base 7 of x squared equals log base 7 of 8x minus 15. So because these both have log base 7, this is, it's an idea same as exponential. We call it 1-to-1, but like because those are the same, these must be equal. So we could go ahead and set x squared equal to 8x minus 15. Okay, we have x squared and x, which means we're solving a quadratic, right? We can't just square root method or whatever. This is going to be a factor problem, right? So let's subtract 8x over, add 15 over, set it equal to 0. Let's factor this. Okay, factors of 15 that add to 8, 3 and 5. Both are negative, right? Let's set those equal to 0 and solve, right? And we're going to get x equals 3 and x equals 5. Okay, so there are those, right? And then let's look at B. So you have log base 2 of x to the third plus log base 2 of x minus log base 2 of 2x. Okay, so there's probably more here. I can't, equals 6. Yeah, there we go. Okay, equals 6. So all these are the same base, right? So we can put these together. So log base 2 of x cubed times x is x to the fourth. And they're dividing by 2x. So this is actually going to be log base 2 of x to the third over 2 equals 6. Well, then, because this is all inside here, we're just going to change this to exponential. So 2 to the 6th power equals x to the third over 2. Okay, well, let's do some math here. So 2 to the 6th. So if you have your calculator, right, like this is where you can do it. You can still do these in your head. Sorry, my calculator's being crazy here. I just want the free one. Please stop this. Okay, sorry. So if you had this, right, 2 raised to the 6th power, right, 64. So you would say, okay, this is 64, right, multiply by 2, 128. And then we would finally cube root that, right, which you're going to get like 5 point something, right? So there's B. C, we have log base 7 of x minus 4 plus log base 7 of x plus 2 equals 1. Okay, again, we can multiply these. So log base 7 of, and I'm just foiling these, distributing these. So x squared minus 4x plus 2x, so that's minus 2x minus 8 equals 1. Again, change it to exponential. 7 to the first equals x squared minus 2x minus 8. Subtract 7 over, because we have this quadratic that we need to set equal to 0, right? And so we get this, x squared minus 2x minus 15. We will factor. Factors of 15 that subtract to 2. Look at us get 3 and 5 again. So -5, +3 to give us a -2. We would set those equal to 0 and solve. Right? We would get x equals -3 and x equals 5. Okay. Looking at D, we get 3 natural log of x equals natural log of e to the 5th minus 2. Now, hopefully you see this. You could do this in a calculator, a lot of things you could do here. But hopefully you know that the natural log and the e are opposites and they cancel. So this is just going to be 5 minus 2, which is 3. and you're going to have 3 natural log of x. I would divide by 3 and say the natural log of x equals 1. Now, again, hopefully you would know this one. You might not. So if you don't, just change it to exponential. What's the base, right? It's e. E to the first equals x. So x is equal to e here. Okay, problem E, we have -9 natural log of x plus 1 equals -8. I would divide by -9. I get the natural log of x plus 1 equals 8/9. Again, change it to exponential. E to the 8/9 equals x plus 1. Put that in your calculator, subtract 1, you're going to get x, right? So whatever that is, right? So last one here, F. Okay, we have natural log of x plus 8 minus the natural log of x minus 4 equals 10. Again, we can bring those together. So natural log of x plus 8 over x minus 4 equals 10. Change it to exponential. This is going to be e to the 10th equals x plus 8 over x minus 4. Okay, this one's going to be nasty, right? So this would be multiplied by x minus 4, x minus 4. We're going to have to distribute. That's going to be some crazy decimal, right? But you're going to get x plus 8 equals, right? And we're distributing this like e to the 10th x minus 4e to the 10th, right? So whatever those decimals are, okay, subtract x. I mean, we should be able to solve a linear equation by this point, right? My calculator is just not really good for doing things like this. Using this one, obviously, if you had a TI-84 Inspire, one of those, going to be really easy to get these decimals and just carry them with you. Okay, let's look at 83. So 83, it is known that 10% of a drug is removed from the body each hour. Okay, if 20 milligrams of the drug is given to a patient at time 0, okay, so this is an exponential. So we got to remember a times b to the x. So we got 10 milligrams at time 0. No, 20 milligrams, right? When at 20, sorry, 20 milligrams at time 0, right? And it's 10% is removed. So that, remember, that's 90, it's a decay, but that's 90%. So 0.9, okay, to the x, right? So when will that happen, right? So when will it get to 12, right? So this is x is in hours, right? So we want to know when it will be 12. So this is our equation, and this goes back to where we were at the beginning of the chapter, right? So divide by 20, right? We'll get 3/5 equals 0.9x. Well, again, beginning of the chapter, we were just plugging in and guessing. Well, now we can go log of 0.9 of 3/5 equals x. So we can put this in our calculator now and get an exact answer now that we know how to do that. Okay, awesome. Last one here, 84. If inflation is steady at 5% a year, how long will it take for prices to double? Okay, so initial price, we're just going to say 1 because all that matters is that it gets to 2, right? If our inflation is 5%, our rate is 1.05, right, x. And so how long will it take to double, right? So we just want to know, when is this y going to be 2? So again, we would divide by 1. So this would be 2 equals 1.05x. Change it to a log. Log of 1.05 of 2 equals x, right? And so then we could put that in and we could get our deal there. Okay, so there's some math notes, your basic properties again, right? And this is lesson 5.